Hey guys, okay, we're doing a video for 2-2, finding sides using trig, or finding the sides of triangles using trig. This guy is trying to figure out the height of this guy here by using a calculator. That is what I'm going to show you how to do, is how to find a side of a right triangle. So we got to start with the three trigonometric ratios. Now there's a whole bunch more, but this is just what we're using for our purposes. So sine of theta. The way we find the ratio for sine of theta is we use the opposite leg and the hypotenuse. The way we find the cosine of theta is we use the adjacent leg and the hypotenuse. The way we find the ratio for tangent is we use the opposite leg and the adjacent leg. Now, there is an acronym that we often refer to, and that is SOHCAHTOA. One thing you want to do is write that at the top of every page or test where you know trig is going to be present. All right, let's take a look at the first example. So the first thing I want to do for this problem is I want to label my triangle. If I could label my triangle and figure out my orientation, then from there I could understand which trig ratio I have to use. I'm going to draw an arrow straight out from this angle. This is my reference angle, or theta. And this is going to be the opposite leg. Then across from the right angle is the hypotenuse. And this is the adjacent leg. Okay. From there, I have to look at what they give me and what I need to do. So they gave me the adjacent leg, and they want me to find the opposite leg. So they gave me the adjacent leg and want me to find the opposite leg. When I look at these, I have sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. So I look back, and they gave me the adjacent leg, and they want me to find the opposite. So I'm going to use tangent. So tangent 24 equals x over 12. All I am doing is taking the information that was provided to me by this triangle and plugging it into this trig function here, or this trig ratio. Now I need to solve it. So I'm going to place a 1 underneath tangent 24. Let's respect something before I go and solve this. Tangent 24 is a number. There it is, 0.4452. Before we've come up with scientific calculators, they used to have trig tables, and you would have to find a decimal that is tangent 24 through that table. Now, thanks to the calculator, we can punch in tan 24, and the calculator will know to convert that to the decimal that is a result of that ratio. So now, from there, I'm going to cross multiply here, and I'm going to get 12 times tangent 24 equals x. I have x by itself. What I can do is just multiply that, or punch that into the calculator. And my answer is 5.34. So 5.34 is the length of this leg. Okay, let's take a look at the next example. Number 8. I'm going to do this again. I'm going to label my triangle. So draw an arrow right out from my reference angle, and that is the opposite leg. Then across from my right angle is the hypotenuse. Then what's left is the adjacent leg. Now what I need to do is figure out which trig function or ratio I'm going to use to solve this problem. Well, they gave me the opposite leg, and they want me to find the hypotenuse. So sine is the one I'm going to use. Sine 15 equals 16 over x. And now, just like before, I'm going to solve. I'm going to solve by putting a 1 underneath the sine 15, then cross multiplying. So x times sine 15 equals 16. X is not by itself, so what I'm going to do now is divide by sine 15 on both sides, and then plug that into the calculator. So 16 divided by sine 15. Whoops, and I get this. Okay, I could hit the button to convert that to a decimal, and there we go. That means that this guy here is 61.82, whatever units it is, long. Okay, next. All right, got two more going. So I'm going to label this triangle. I picked this one because it's a little disorienting. It's all rotated. So this is the opposite. Across from the right angle is the hypotenuse. And this is the adjacent. They gave me the adjacent leg and they want me to find the hypotenuse. So cosine is what I'm going to use. Cosine 58 equals 12 over x. Going to cross multiply. So x times cosine 58 equals 12. Now again, x is not by itself. So I'm going to divide by cosine 58. And x equals, so let's take a look. I'm going to use my fraction button this time. Cosine 58. And there we go. So 22.64. One thing you want to make sure, as I'm realizing, is you want to make sure that your calculator is in degree mode. If your calculator is in rad mode, it will not work. Okay? So keep that in mind. What will happen is you will get the answer in radians, which is not useful for us here. All right, last example I'm going to do. I know this is a bit of a long video, but I want to do some extra examples. A kite string makes a 30-degree angle with the ground. If the kite is 100 feet high, how long is the kite string? So I'm going to label my 100 feet right here. Then I'm going to label my triangle. So this is opposite, hypotenuse, and adjacent. Now, the kite string is the hypotenuse, and that's what they want us to find, and they gave us our 100 feet height. All right, this goes back to how tall is the triangle. So now what I'm going to do is I'm going to use sine 30 degrees equals 100 over x. Then I'm going to cross multiply by placing a 1 underneath. So that's 100 equals x times sine 30. Now what I'm going to do is divide by sine 30. Sine 30. And let's see what we get. Now remember, we want to know how long the kite string is. So 100 divided by sine 30. And the answer is 200. So the kite string is 200 feet. Okay guys, I hope you guys found this video helpful.